Hello everyone. In this tutorial we're going to look at some methods of sorting. This is going to be a series of videos on different types of sorting, and we're just going to use a very basic program to demonstrate these different sorting algorithms. So we're going to look at a couple of very common ones but aren't very effective. We're going to look at bubble sort and we're going to look at insertion sort. And these two are two of the most basic ones out there, but again, I say they're not very good. We're then going to have a little look at quick sort, which is much more optimized, but a little bit harder to understand. And then if we get the chance, we're going to look at shell sort, which is a far more complicated version of insertion sort, but is far better at processing numbers and crunching the numbers and doing it in a short space of time. So, as always with our projects, we're going to start by starting up a sketch, and we're just going to add our void, get my fingers on the right buttons, set up, and there we go, and open closing brackets. Inside here, we're just going to put a size. Let's go 400 by 400. That makes it nice and simple. That's our square. And if we run this, we get our square coming up. Here it is, nothing in it. All right, so we're going to still have our draw function. So void draw, which is our update loop. And at the moment, we're going to stick nothing inside it because we don't need anything inside it for this program. Actually going to be using this little window down here. So this little window down here, if you select the light blue bar here, you can drag it up and down. And this is actually the console, and we're going to be using the console to write things out to the console, like our list of numbers when we have them in a randomized order, and then our list of numbers when we have sorted them. And we're also going to output the amount of time it took the program to actually complete the task. All right, so we are going to need a list of numbers. So we're going to use an integer number, and we're going to put square brackets around it. Square brackets. And inside this, we don't put anything inside those square brackets. And we're going to put a variable name. I'm just going to call them numbers to begin with. And we're going to make that equal to a new integer array, and this is where we're going to put how many we're going to do. To start with, we're just going to put 100 numbers in there. Now, they haven't been set up yet, but we're just making up the space for 100 numbers. Now, this is all we're going to actually have in this file to begin with, and we're just going to do a couple of little things with how we're going to get the program to run. So we're going to use the left and the mouse button to create our numbers and then sort our numbers. So our left button click will do, mouse click will do creating a random list of numbers of 100 at the moment, and then our right click is going to use the sorting method that we're going to pick. So we're going to write up that. Now, okay, so we're going to go new tab, a little icon, go new tab. We're going to call this tab just the controls for our program, and bang. Alright, so in controls, what are we going to need? We are going to need and it's just a function that you can use in processing called mouse press. And that just runs whenever the mouse is pressed. Any mouse button is pressed, so if the left, the right, or the center mouse button is pressed, and we're going to define which one's pressed. So we're going to use an if statement, and we're going to go if, open bracket, mouse button, make sure you get the capitalized B, make sure it becomes pink, equals, so that means it's equivalent to the left, and that's all going to be uppercase because it's a special name. And we're going to put our circle brackets around what we want to have happen when the left mouse button is clicked. Now we're also going to do the exact same thing, so below that, in between that bracket and our bottom bracket for our mouse pressed, we are going to put another one. We're going to put another if statement. If mouse button is equal to right. Whoa, it's got to be capitalized. Make sure you capitalize it, otherwise it won't work. and we're going to put in our brackets again. I'm just going to clean up some of my brackets. There we go. They're all indented nicely. Just remember you can hit Control T on the keyboard, and that will make sure all your code in both your files is beautiful and neat. Alright, so that's what we've got there. That's what we got there. So the first thing we want to do is we want to actually just get it so when we hit the left mouse button, it populates our list with the random numbers and displays them to our console down the bottom here. Alright, but before we do that, we need a little bit more information in our main file, and we're going to put some information just above our setup. So we're going to have another integer, but this is just going to be a single integer. We're going to call it size. So this is going to be the size of the array. So how many numbers do we have in an array? Not what are the numbers, how many numbers are. So we're going to go numbers.length. There we go. And what's that's going to get is that's going to output this as 100. If I change this number to 1,000, it's going to output 1,000, but we don't want to do that at the moment. All right, and we're going to put in just a couple of other little things. We're going to put in a float. Just remember that's a number with a decimal point. Before is equal to 0, because we don't want to set to something, and float after is equal to 0. All right. What they're going to be used for later on is to test how long it took for us to do our argument. We don't need them yet, but we're going to just put them there so that that whole file setup, we don't even have to touch that file again. We're just going to go back into controls. So in our controls, excuse me, we are going to print to the console. To do that, we can use two functions. We can use print line. That will print whatever's inside print line, and then enter. Hit the enter key, so return key, enter key, whichever one you want to call it, and it'll put it down onto the next line. So this is like a string of text, and we can break it up through lines. And the other one we can use is print, which doesn't create a new line when it does that, and it just adds on to the end. And that's what we're going to do here. And we're going to put numbers inside there, put a couple of spaces in, and just remember that you need your opening and closing quotation marks to indicate a string. And that's what we're displaying to the screen, a string. So if we run that now, we have our print line, our print numbers with a few spaces. So if we run this now, and nothing shows up. Nothing shows up in our box. Nothing shows up in our console down here either. If I left click on it, ta-da, we have numbers popping up down the bottom. And if I left click again, ta-da, and it'll just keep popping them down as I left click. Right click at the moment will do nothing. That's good. So we got our numbers. Now we want to add to our, we actually want to put our numbers in. So below this, what we're going to do is we're going to put a for loop, and we're going to iterate through our whole array. So our for loop is we're going to get our just standard counter, and we're going to call A is equal to 0. So A starts at 0, and we want it to go all the way through to our highest number, which is 100. Now, what's special about arrays is, even though we have 100 elements in our array, the first one is actually called 0. So we've got from 0 to 99, which is still 100 elements, but we always have to start at 0, and we don't want to go past 99, because if we try and go past 99, the program will crash, it won't work. So A is less than, and just remember that variable we created. We created that variable called size. Did I capitalize my variable called size? No, I didn't. There we go. So in our other file, we put size, and it's got the length of the array, so it's got 100 at the moment. Just remember that might change in the future. Semicolon, and we want it plus plus. That means add to it by 1 each time we iterate through our for loop. So it starts at 0, then it goes to 1, 2, 3, all the way up to 99. Not 100, because we can't go outside of our array. All right, now here we go. Numbers is the name of the array, and now we put a square bracket and we put A inside. That's going to get whatever A is equal to. When it first goes through, A is equal to 0, so it's going to get the first position in an array, And we need to set it to something. So when we set it, we make it equal to something, and we want it to be an integer, and we want it to be random. And we're going to put it random between 1, let's go with 1, and 1,000. So it can be any number between 1 and 1,000. And just remember, you got to close off your brackets. You got 1 here and 1 here open. So you got 1 closing and another 1 closing. And then we put a semicolon at the end of the line. Oops. Something's gone wrong. And there we go. My program just didn't quite update. So it just had a little glitch in it. It's alright. Nothing has gone astray. Now, that's going to create our number, but it's not going to display it to screen. How do we display it to screen? You're asking? Print. We're going to use print. So inside our for loop, we're still inside our brackets here and here. So we're inside it, and we're going to write print, open bracket, numbers, because that's in our array. We're going to get our A point, so position 1 to start with, and then we're going to do something special. We're going to put a plus symbol. Now, why we're putting a plus symbol is we not only want it to display the number, but we want it to display a comma afterwards, so we can split our numbers up, and a space, and our closing comment, and ta-da. Now, what's this going to do? It's going to now display numbers, all the numbers in our array to screen. How many have we got? 100. Let's not make it 100. Let's make it 10 so we can count them. All right, so let's go back into here. And left click, and oh, here we go. So we can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We got 10 numbers, and they're spread apart, and they've got commas, so we can read it easily. Hooray. We've got, but there, look at them. They're all random. 780, 262. Completely random between between 1 and 1,000, because that's what we put in here. I put 1 to 1,000. All right. So now, if we wanted 100, let's go back to 100. So in our main sketch, let's put 100 in. We run our program again. Pops up with our screen. Nothing shows until we hit the left mouse click on the square. Bang! It drops in 100 numbers. I'm not going to count them all. I'm just going to assume there's 100 there. Should work. Alright, close that off. Alright, so we have got it displaying what we need it to display. Now, if I run that again and click it again, you're going to get a bunch of random numbers again. If I click it again, guess what? You're going to get another bunch of random numbers. Because every single time we left click, it resets them to a random set of numbers. That's pretty good. That's what we want. Alright. Now, when we right click the mouse, what do we want to have happen? We're just setting up the interface. We haven't even gone into solving using sorting methods or anything like that just yet. But we'll get into that in just a minute. Alright. So we want to display the array after we've sorted it. And now, instead of having to type it all out again, because who wants to do that? We've got this for loop. We grab the whole for loop. Control C on the keyboard, click down here, Control V, and bam. Now, when we click, left click, and then we right click, guess what? It displays them all again. Now, it just added them all onto the end of our line. That's not very useful. We probably need a print line up here. So we're going to put a print line. Just remember what a print line does. Inserts and enter, so it inserts a space. So we left click, ta-da, we've got all our numbers, right click, ta-da, it displays all our numbers again. Guess what? They're still in order. Now, something didn't work quite right just then. Oh, I know why. Because we have still got this in here. So it's resetting them all again. We don't need that line in there. Delete that line, get rid of it. All we want is our print. So it should print the same set of numbers. Ooh, that was tricky. So we click. There we go. 152 should be our first one. Bang. 152 is our first one again. We can check and we can see. Yep, we can see it. All right. That's good. That's good. All right. That's all we're going to do up in there for a minute. Now, we've set up so that we've made it so it picks random numbers. All of them. And then we've displayed it afterwards, but they're not sorted yet. So let's go ahead and sort. All right. we've got our main function. We haven't touched that one. Guess what? We're not going to touch it again. We've got our controls. So we've got our mouse pressed. We've got our mouse if the left button's pressed, the mouse is right button pressed. We're going to add a new tab. Go to the new tab, click new tab, and we're going to start with insertion. And we're going to start writing just a little bit of code to get insertion sorting going. All right, so we're going to create a function. It doesn't have to have an output. We're just going to create a straight up function, void, and we're going to insertion sort. Let's put a capital there. Sorting. All right, bang. That's going to be our new function, and we need to do something. So we put squiggly brackets underneath it, and it does nothing at the moment. So first thing we want to do is remember how big our array is, and well, we're going to do that is we are going to go ahead and we need to iterate through all our numbers, don't we? Yeah, we do. Okay, so let's do that. For int, we're going to use I this time just for something different, is equal to 1. Oh, so we're going to start at 1. Why? Because I'll tell you in a minute. Because there's an extra step. We're not starting at 0, not starting at the first element, we're starting at the second element. Ooh, that's interesting. I'll tell you in a minute why we're doing that. And I is less than, remember what we had before? We had size. Size was the length of our array, which is at 100 at the moment, I think. Plus plus I. Alright, so we're increasing each time we do this by 1. But we're not starting at the first one. Why? Because we want to check the second one against the first one. So we start at the second one and we look at the first one. And we go, ooh, are they the same? Are they greater? Are they smaller? So what we're going to do is we're going to make a little key. Alright. And what this key is going to do, it's going to be a very useful little key. And we're going to get the integer and go key. And we're going to make that key equal to numbers, because that's our array, and I. So we're getting the second element to begin with, key. And now we're going to use that key. And we also want another integer, and we're actually going to get the element before it. And we're going to call it j, just for something different. Alright, we can use anything for these numbers, -1. Alright, so that's the position before it. So that is 1, -1 is 0. So j is now equal to 0. Alright, so if this element here is greater than our key, so if the actual number in j is greater than the key, then the key and j are going to swap. And then the key is going to move up 1. So it's going to keep moving up our array list. And how we actually do this is it's a little bit tricky to understand. So if you got the number, let's say 7 as your first, as in your 0 position, and 2 was in your second position. Now, 7 is greater than 2. So 7 is going to get moved up. And guess what? That means we're going to move j across. So how are we going to do that? We're going to do a while loop. While. So we're doing something until something happens. Okay? Alright. And what that means is what we're actually doing is we're moving until our j, well, we're moving while j is greater than or equal to 0, so it can't go backwards. Don't want it to go backwards. Don't want it to get to -1. That would be a bad thing. But we're going to keep moving the number in j until it's greater than the number that we started with in I. So what we started with in the key. Alright? And we're going to keep doing that, and it's going to keep moving across until that becomes true. All right. So we've got J is greater than or equal to 0. That was our first thing. It had to stay greater than 0. Don't want to go -1 because that would just crash our program. All right, and then numbers. So the number in J, position J, which is 0 at the moment, is greater than the key. And the key is, just remember, our second value at the moment. All right, so we're going to keep doing this. And what's going to happen is the number so J is going to move across. All right, so J is going to be increased. And what that means is we're going to move it up 1. If this is true, we're going to move it up in the array from 0 to 1. Yeah. Okay. Does that make sense? That's what we're going to do. All right. Numbers. And we're going to get J plus 1 is equal to numbers J. Oop, I've missed a 1 there. There we go. What that did is it just moved it up. And I can't spell numbers. All right. What that means is now J can be equal to J minus 1. Now that might seem a little confusing. All right. But what this means is we've just moved J up 1. And then what's happened is J has gone backwards, which means it become, if it was at 0, it's become -1. So our while loop stops for the first round, our while it stops. All right. And that's what we want it to do. We don't want it to keep going outside of 1. And now that means we are setting numbers dot J, because what's J now? J is -1 plus 1, so that's 1, position 0, -1 plus 1 is 0, equal to the key. And guess what? That just actually swapped the key and J around for the first number. All right, so we just swapped them. Just swapped them, straight up swapped them. All right, Control T formats it nicely. Now, what this will keep doing, if we keep running this program, it just keeps going up and up and up, and once that's happened, guess what? I becomes 2. And then we find out what's in position 2, and say that's 3. And J we now already know is 7, so it'll move up, and it'll keep moving up until J goes back to -1, and then that's where we move the key to. So it's a little bit confusing because J goes up and down, but we're always checking against the key. So it's actually the key that's we're trying to get into position. It's actually the key we're trying to get into position. J is just the one moving out of the way so that the key gets in the right spot. All right. That's how this algorithm works. So the key just pushes everything behind it until it fits into the right spot. And it keeps picking things and pushes everything backwards in the array until it finds the right spot. And it keeps doing that until every single number has been put in the right place by pushing everything else that's bigger than it behind it. And if you keep doing that over and over and over again, you will get the smallest to the highest number. So we've written this now. Let's see if we can run it. I'm just going to copy insert and sorting up. Gonna Control C, and then I'm going to come down into here, and where we are right clicking, this is we're going to paste that, put a semicolon at the end of it. So what's going to happen, Control T to make this look nice and pretty, what's going to happen when we hit right click is it's going to run this function in here. And when it runs through this whole function, hopefully our numbers array, when it's printed out, come out correctly. Here we go. We're going to click start. Left click gives us a random bunch of numbers, 100 of them. Right click, oh, look at this. 1, 12, 13. If you look through all of these, you'll find that they are all going up and up and up and up, and there's no numbers out of order, which is exactly what we want. So it's worked. Insertion sort has worked. But it means that every single number has been checked basically against every single number, which is very slow. See, like our 13 right here, it's had to go through every single one of these to get to where it needs to be, which is the third one in the row. So it's had to do a huge number of calculations to do that. Now, it's running very quickly at the moment, but let's actually see how fast it's running. So what we're going to do is we are going to input some extra little bits of information that will allow us to see how long it's taken for the program to actually do this process in the background. Alright, so do you remember these two variables we use, before and after? We're going to use them now in our controls and in our mouse button when we click the right mouse button. So we're going to go before is equal to milliseconds. And this is a special function. What it does, it calculates how many milliseconds have passed since the program started running, and we're going to put that into our float. And then after we've done our insertion sort, we are going to do after equal to milliseconds. And guess what? That's going to get how many milliseconds it took for that process to happen in between. So one before is going to be, say, 100 milliseconds. After might be 102 milliseconds. So it took 2 milliseconds for that process to run. How are we going to display that to the screen though? How are we going to write that to the screen? What we're going to do is below here, we're going to write this to the screen by going print line. We just need a spacer in there. And then we're going to go print line again, but this time we're actually going to put in how many milliseconds it took. And how we're going to do that is we're going to go after the longer one minus before, which was the shorter one, plus, and this is where we're going to add just a bit of text so we can read it. Milliseconds, close out squiggly brackets, close that off, and put a semicolon at the end. All right, let's run this program again. Click. All right, left click shows us our 100 numbers. Right click. Oh, it shows us them sorted. It said 0.0 milliseconds. It was so fast that it couldn't even pick up that there was a millisecond between the calculation happening and the calculation finishing. So what are we going to do? Let's bump up how many numbers we do. Let's do 1,000. Alright, let's run it. Bang. Oh, there's 1,000 numbers. Looks pretty impressive. Looks pretty impressive. We can drag this up so we can see them all. Alright, let's just go back to our program. And now I'm going to right click. Oh, it sorted them, but oh, that took 2 milliseconds. How many milliseconds are there in a second? There are 1,000 milliseconds in a second. So it still did it very, very quickly. Alright, let's stop our program. Let's bump it up by another factor of 10. 10,000 numbers. Left click. Oh, populated 10,000 numbers into our program. Look at that. That's huge. There are so many numbers there. Alright. If we right click on our program, ooh, that took 52 milliseconds. So we're starting to see it's starting to take a little bit longer for the calculations to happen. And, oh, do I attempt it? 100,000. Let's run this. Left click. Take a little bit of time to populate. Right click. Oh, what's happened? Whoa, that took a long time. That took 4,783 milliseconds. So that actually took 4.7 seconds to run. Now, the first time you run the algorithm, it actually takes longer. So if we left click again, it'll repopulate with a randomized list, and we right click again, it'll actually do it a little bit faster because it's done the sort before, so the computer optimizes itself and it calculates just a little bit quicker. So that took a second. All right, so you can see how as you increase the numbers, it's going to take longer and longer to do things. Now, if I go to 1,000,000, I might crash my program. So let's have a little look. Left click. Oh, it's populating numbers. It's taking a while just to do that. Right click on, and I'm just going to leave it. This could take a bit of time. And this is a good demonstration of how long some of these algorithms take when they do lots of calculations. And it's still going. I might have actually crashed my program. Just going to wait for it. Just going to wait for it. And hope that it actually does it. I don't think it's actually going to do it. It's still processing it in the background. Still doing it. Hasn't crashed the program. We can still move the program around. It hasn't completely crashed the program, but it's taking... I've been talking for the last 30 seconds. So that's just a good indication of what programming algorithms do, and shows how ineffective some bits of code are. Because we're going to do a couple of other ones in the next tutorial, and they're going to be a lot faster. Well, one of them will be. I don't know if the other one will be. That's what we've got to find out. Alright, so we're going to leave it there. Make sure you save your project. I'm just going to turn that off because it just didn't calculate it. It didn't come up with an answer. Still trying to run. No, it's not working. Alright, let's just pull this down out of the way. So, what have we got? We've got our main sketch. We've got our array, our size of our array, our before or after for our timer. We've just got our setup and our draw function. In controls, we've got our mouse press. What happens when we click our left mouse? We just display a randomized list. When we click right, at the moment, it does insertion sorting. And what is insertion sorting? This is our insertion sorting algorithm. Looks very small, quite powerful, but not powerful enough yet. Alright, I'm going to leave this tutorial here, and I hope to see you in the next tutorial where we look at bubble sort, and then we'll move into quick sort and shell sort.